Here are the answers to your triangle sum theorem homework. We just gave you this homework. We didn't teach a lesson because we know that you already learned that the measures of the angles of the triangle add up to 180, always, no matter what type of triangle it is. So check your answers real quick and we'll move on with today's lesson. All right, let's move on to our lesson. If you want me to go over a homework problem, I can do that at the end. Write down in your notes what a polygon is. The definition of a polygon. This definition has a lot of good words in it. They are each important. It is a closed plane figure with at least 3 sides that are segments. We're not going to talk deeply about polygons in this unit. We're just going to say what a polygon is, and then we're going to zoom in and only talk about triangles. So the name of this unit is triangles, but a triangle is a type of polygon, so we wanted to remind you what a polygon was to begin with. Laying the groundwork, laying the foundation here. So like I said, each of these words is important. It needs to be a closed figure. So this, for example, right here, would not be a polygon because not all the sides are connected. It is not closed, it's open. The opposite of closed, right? It needs to be a plane figure, which means the vertices of the polygon need to be coplanar. So you can't have 3 of the vertices of the polygon here and another vertice up here. There we go. That would be a 3D figure, not a 2D figure. That would be a solid, not a polygon. Okay? It needs to have at least 3 sides, so 3 plus. And the sides need to be segments. That means a circle is not a polygon. That means a part is not a polygon. So the sides cannot be curved. That means a half moon is not a polygon. It's a shape, it's just not a polygon. It's closed. It's a closed plane figure, but the sides are not segments. So the sides can't be curved. Another rule is the sides cannot intersect. No intersecting. So when the sides cross each other, that's not a polygon. It kind of creates 2 separate polygons, but the figure as a whole is not a polygon. All right? All right, there are 2 types of polygons, convex and concave. I honestly really just want you to look at this slide. I don't want you to write it down. We're going to focus more on these next semester, but I wanted you to know what they are. A convex polygon is pretty much every polygon that you encounter. The ones you're used to seeing, those are probably all convex. In contrast, a concave polygon is where one or more of the sides has quote-unquote caved in. So notice what the concave polygon looks like. I'll outline it. This is a concave polygon. So notice that the sides right here and here, they're jutting in to the interior of the polygon, kind of, and that is concave. You do not encounter these as much, and we don't solve problems with concave polygons. All the times that we're going to solve for measurements or angles, they're always going to be convex polygons. So just wanted you to know the difference. Concave, think that the side caved in. If any of you wear contacts, or when you're in biology class or chemistry class, you'll talk about lenses and how they can be concave or convex. A convex lens looks like this. Like when you normally put it on your eye, it's like this. A concave, it's when it's like caved in like this. It droops down. And if you put a concave contact in your eye, it really hurts. And you like blink it out because your eye like rejects it. You put it in wrong. Okay. So, is the figure a polygon? If so, is it convex or concave? Is that first figure a polygon? Well, it's following all the rules. It's a closed plane figure. Its sides are segments. So yes, it's a polygon. But it is a concave polygon because one of the sides is caved in. The next one, is that a polygon? It is not a polygon because we learned that the sides of a polygon are not allowed to intersect, and so that's not a polygon. Finally, yes, this is a polygon. It is a convex polygon because none of the sides are caved in. That's all we're going to talk about. Like I said, next semester we'll dive more into that. I only want you to write what's in pink on this slide. You don't need to write what's in red or orange. You only need to write what is in pink, okay? An equilateral polygon. So equa means equal, and lateral means sided. So it's a polygon that's equal-sided, okay? So an equilateral polygon has, my computer's freezing out, all sides congruent. You're not writing that down. An equiangular polygon is just like it sounds. It has equal angles. So an equiangular polygon has all angles congruent. And then the one I do want you to write down is a regular polygon. I want you to put in your notes what a regular polygon is. It is both equilateral and equiangular. All sides congruent, all angles congruent. Write down the pink one only, the regular polygon. Just for kicks, let's name all of the polygons starting with triangles. Not all of them. Let's name the first 10 polygons starting with triangles. So if a polygon has 3 sides, then it is a triangle. If a polygon has 4 sides, then it is a, don't say square, quadrilateral. Now, what would a regular quadrilateral be called? Square. That would be a regular quadrilateral. But a 4-sided figure is called a quadrilateral, not called a square. If a figure has 5 sides, then it is called a pentagon. Good. If a figure has 6 sides, then it is called a hexagon. Good. Thank you for using your mic. If a figure has 7 sides, ooh, this one you don't use as much. There's 2 different words for this one. I just picked one and put it up here. Heptagon. Sometimes people refer to it as a septagon, but I use heptagon. Next one, if it has 8 sides, then it is called an octagon, like a stop sign, right? If it has 9 sides, then it is called a nonagon. Good! Nonagon. You even pronounced it correctly. And if it has 10 sides, then it is called a, good, like a decade. Yes, a decagon. 12 sides is called a dodecagon. But anyways, all right, that was just for fun. Here's where we get into the good stuff. This is today's lesson. All right, let's classify a triangle by its angles. So, classify means to put into a group, right? I could classify people by their height. I could classify people by their weight. I could classify people male, female. I could classify you by your grade level. It just means to put you into a group. If I'm going to classify a triangle by its angles, there's 4 ways I could do that. If all angles are equal, it is called equiangular. If all 3 angles are less than 90, it is called acute. Just like the angle, less than 90. All 3 of them have to be less than 90 to be acute. If 2 of them are less than 90, but not the 3rd one, it is not an acute triangle. How many angles have to measure 90 for it to be called a right triangle? Well, only 1 angle. Could a triangle have more than one 90-degree angle? No, not possible. Finally, if one angle measure is greater than 90, it only takes 1. If one angle measure is greater than 90, then it is called an obtuse triangle. So these are the 4 words we could use to describe a triangle by its angles. This is old news, so I'm just going to keep going, okay? You can go back and look at it or look in your online textbook if you're allowed to log in. We're still working on that. What if they all measure 60 degrees? Then it is both equiangular and acute. Good question. It is both. It is double dipping, right? All right. Ooh, what is this called? If you had to take those 4 words that we just learned and put them into these circles, where would you put them and why? It's kind of like a Venn diagram. It's a logic organizing. It's a graphic organizer. Okay? Now, if one circle is inside the other one, it means everything that is that vocab word is also the other vocab word. Similarities and differences, kind of, yep. Okay. So, I'll just let you know that obtuse and right would go in those two. So now we have acute and we have equiangular. Which one goes in which circle? Are all acute triangles equiangular, or are all equiangular triangles acute? Get it? All equiangular triangles are acute. Because if a triangle is equiangular, its angles are 180 divided by 3. And a triangle who has 60-degree angles is always acute. Okay? So that's, now, could a triangle be obtuse and acute at the same time? Do those circles overlap? No, they don't overlap. So it's saying that those are their own circles. If a triangle is acute, then it is not right. But if a triangle is acute, it could be equiangular. Hope that makes sense. Now let's classify. Let's sort a triangle by its sides. I bet you already know these. This is old news, not exciting. All sides congruent, equilateral. At least, notice this is key. At least 2 sides congruent. Isosceles, we'll talk about why that phrase is there. And none, no sides congruent. All 3 sides are different measures. Scalene, say that out loud. Say scalene out loud. You can use your mic or not use your mic. You can just say it at your school. I just want you to be able to pronounce that word, scalene. All right. Always, sometimes, or never. An equilateral triangle is isosceles. Always, sometimes, or never. So an equilateral triangle has all sides congruent. All sides congruent. An isosceles triangle has at least 2 sides congruent. I didn't write the word least. So if a triangle has 3 sides congruent, does it have at least 2 congruent? Always. Always. So an equilateral triangle is always isosceles. Now, is an isosceles triangle always equilateral? Sometimes it is, sometimes it isn't. I call it a promotion. If an isosceles triangle has a 3rd side congruent, it gets promoted to equilateral. It could or it couldn't. So this one's a sometimes, whereas the other one isn't always. Okay? Okay. So would it be wrong? Is that triangle right there, is that triangle isosceles? Oh, it's not showing up yet on my screen. Yeah. Is that triangle isosceles? Yes. But a better name for it is equilateral. But it is isosceles as well. It is both. All right, so if we're doing sides now, how would we organize this graphic organizer if we're doing sides? Which one goes in the empty one? Which I don't know why I didn't put a little thing there. Who knows? Which one goes there? Yeah. All right, and then which one is always the other? Equilateral is always isosceles. I think I spelled that right. I-S-O-S-T-E-L-E-S. Okay. Let's name these. We're going to do it really quickly. Don't write this in your notes. This is just for fun, for practice. Number 1, what's the name of that triangle? You could use the word equiangular, or you could use the word acute. We have not learned the theorem that says if a triangle is equiangular, then it's equilateral. So, excuse me, you would not put equilateral for number 1. Does that make sense? If I give you angles, you name it by its angles. If I give you sides, you name it by its sides. Okay? Number 2, equilateral. Yes. Number 3, go ahead and say it. Scalene. Good. Number 4. Obtuse. Very good. Number 4 is obtuse. Number 5. The opposite of wrong. Yes, right. Number 6. Acute. Very good. Some interesting spellings there. And lastly, number 7. Isosceles. Awesome. 9 is equal to 9. It has 2 congruent sides, so it's isosceles. Okay, let's get to the good stuff. This is knowledge you already know. It was used on your homework last night. I just wanted to show you pictorially how it works. The angles of a triangle sum to 180 always, and we know that. But the reason is if you take each one of those angles and you align them right here, if you put the angles adjacent to one another, you will notice that all 3 angles together form a straight line. Did you see how if I use the angle addition postulate, I could add the red, the pink, and the orange, and it adds up to 180. They form a straight line. A straight angle has 180 degrees, and that's why the angles of a triangle add up to 180. We will do a proof of that later. So there's your triangle angle sum theorem. I'm not going to give you time to write this down because you already know this. There's another theorem we're learning today that I will give you time to write down. Alrighty. Here's today's new theorem of the day. It might be new, it might not be new. We are going to discover what the exterior angle theorem is. In order to do that, you need to write down these new vocab words. So we have remote interior angles, and we have an exterior angle. Write these down, and then or draw the picture, and then I'll talk about them. So, you know when you're sitting on the couch and you want to turn the TV on or you want to change the channel, you use a remote control, right? Or when you're like flying an airplane that you built or something, you use a remote to control it. So remote, I want you to think of far away. It's when you're far away from the device and you want to control it. So these 2 angles, I'll just call them 1 and 2. In the triangle, these 2 angles are the farthest away from this exterior angle. So they're called the remote interior angles. Now, of course, exterior means on the outside. So the exterior angle is angle 4. It's the angle on the outside of the triangle. We're going to learn what the relationship is between the remote interior and the exterior. All right, so let's use my smart board trick. I'm going to take my pink angle 1 and I'm going to place it right here. And then take my orange angle 2. I'm going to do some rotating, which does not change the measure of the angle. And oh my goodness, what can we conclude from that? They fit perfectly, like a puzzle. What could we conclude? Yes, we can conclude that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. That means the sum of the remote interior angles is the exterior angle. Here's the official theorem. I need you to write this down in your notes. You will be asked about this theorem again, so you do need to write this down in your notes. Let me say one thing about this exterior angle theorem. Students totally get this theorem, but they forget to use it. I call it a shortcut theorem. Do you have to use this theorem most of the time? No. You could solve for angle 3 and then you could find the linear pair for angle 3, but it's a shorter way to the answer. So this is a shortcut that we're teaching you. Most of the time you don't have to use it, but it makes your life easier and faster, which we all need. Okay? So just don't forget to use that theorem. All right, let's practice. I'm not going to give you enough time to write down this whole example. We're just going to do it and you're going to watch. All right, so while you're getting used to it, you can circle the remote interior angles, and we just learned a new theorem that says their sum equals x. So literally, to solve for x, we would just say x is 51 plus 45. X is a 96-degree angle because we have a theorem that told us so. Next one. Circle your remote interior angles. 44 plus 90 equals x. X is the obtuse angle of 135. Easy as that. All right, I will give you a minute to solve this one, throwing some algebra in there. Thank you for correcting me. Way to go. 134. Doing things too quickly. Good eye. All right, number 3. Good eye. All right, so our theorem tells us that the sum of the remote interior angles equals the exterior angle. So that would be the setup for the problem, and we revealed that the value of x was 5. Good job. So how do you set this up? You add your remote interior angles and set it equal to your exterior angle. Okay? Fabulous. Solve for x. Those angle markings, of course, mean that those angles are congruent. That segment is an angle bisector. There's a few different ways that we could start this one. If I really wanted to use my exterior angle theorem, I could. Let's use it just for fun, but you did not have to use it. So if I call this, let's say I've already used up x, so let's say I call this y. This angle plus this angle equals 177, right? So 90 plus 2y equals 177. You could just subtract 90 and divide by 2. All right, so you do get a decimal answer. Y is 43.5. And then, of course, to find x, you can use triangle angle sum theorem. Triangle angle sum theorem. And you can add 90 plus 43.5, and you can subtract that from 180. Final answer of 46.5. Very good. That was a lot of arrows. 46.5. Or a lot of markings up there for a not very difficult problem. All right, what was another way we could have solved that? Let's look and see what else we could have done. Because I am telling you, today you remember this theorem, but other days you're not going to remember to use this theorem. Students struggle with that. You could have found the linear pair of 177, right? Which is weird. It's like 3, right? And then you could have just used this triangle, and you kind of would have had to do the same thing. You find the missing angle, and then you're going to have to divide it by 2. So you could do 180 minus 93, and then you're going to have to divide it by 2. So, okay, good. In order to bisect it. All right, here is a summary of what we learned and used today. 2 theorems that we will continue to use, and then your homework will help you practice that exterior angle theorem much more extensively. So, that was a short and sweet lesson, huh? Not too bad. Make sure you do your homework. We'll check it on Monday.